Now, for the class practice, explain which molecule CH2 or Cl2 or CH2 F2 is more polar. Now, for consideration of the more polar or less polar, you have to think about the difference of the atoms. So you will find that chlorine has the less electronegativity than fluorine. That is, the CCl bond is less polar than CF bond because F is more electronegativity than the carbon. Then the difference will be larger, or the F having a larger or more electronegativity than chlorine actually. So the net effect of the two polar bonds are greater for the CH2F2. Another one, arrange and explain the increasing order of dipole moment for CH2, F2, CCl4, and then CH2Cl2. Now we have said that this is the highest. However, CCl4, because of the shape of its molecule, it is here. It is tetrahedrally arranged. They cancel with each other. As a result, it should be non-polar. Hence, what will it be? The order will be CCl4 is the least, CH2Cl2, and then CH2F2. We have already decided this one. So the order of the dipole moment is CCl bond is polar. So CCl4 is non-polar because all or the four CCl polar bonds are arranged symmetrically in the tetrahedral molecule shape, and the polarities cancel with each other, as a result, overall non-polar. However, CH2Cl2 and CH2F2, and then takes the tetrahedral shape as well. However, CCl bond is less polar than CF bonds. Then fluorine is more electronegativity than carbon or the chlorine. So the net effect of the two polar bonds are greater for CH2F2. So just the same case as the previous slide. Explain why PF5 is nonpolar while PF3 is polar. Now, we have to think about the shape. For the PF5, it is here, the shape this is for fluorine. This one is the trigonal bipyramidal, while PF3 is the, not PCl3 again. So this is the trigonal pyramidal. So they are having the different shape. PF5 trigonal pyramidal, while PF3 trigonal pyramidal. The shape affects what? The polarity of bonds, whether it can cancel or not. So in PF5, the polarity of the bonds cancel out, while in PF3, the polarity of bonds cannot cancel out. Hence, it will be drawing the electrons to the bottom. We will have the overall polarity. So the dipole moment is going here. This is delta negative on the fluorine side, while delta positive on the phosphorus side. As a result, PF3 is polar molecule, while this one, they are all cancelled with each other. They have same strength, or the polarities of PF3 are the same. As a result, they are cancelled with each other due to its molecular shape. How about SO2 is polar while carbon dioxide is non-polar? Now remember, we are not talking about the number of atoms. We need to think about the shape of molecule. SO2 adopts the V shape, while carbon dioxide, CO2, is adopt the linear shape. So the first thing is about the shape. Here, SO2 adopt the V shape. The polarity of the SO2 cannot cancel with each other. Oxygen bears a higher electronegativity. Overall, it will be like this way, drawing to the bottom. Oxygen bears the delta negativity, while sulfur bears the delta positive. However, for the case for carbon dioxide, we find that the polar bonds are arranged they refer to the polar bonds, are arranged symmetrically. The polarities of the two carbon dioxide CO double bond cancel out with each other. So although it contains polar bond, there is no overall polarities at all in the molecule. As a result, it is non-polar. So what will be the effect of a charged rod on polar or non-polar molecules liquid? So if we want to test whether a molecule polar or not, we can use a charged rod close to the jet of the water. So it has a diffraction. If we have a charged rod, then the polar liquid, that is the liquid which is mated up with the polar molecules, will be attracted by the charged rod. As a result, it will be bent here. There will be deflection. If we have a water jet here, and then if we put a charged rod, you will find that it will be being attracted here. If the jet of liquid is deflected from its vertical path towards the rod, the molecule contains polar molecules. So you can see that it will be deflected here. If the jet of more liquid shows no deflection at all, it just contains the non-polar molecules. The liquid contains non-polar molecule. Now, but one point we have to think about this, if it is positive charge or it is negative charge, it just attracts towards the charged rod. No matter positive or negative, it will not repel the jet of the liquid. Why? Just because the molecules are free to move. They can attract here, the delta negative can go to the positive side, the delta positive can go to the negative side as well. But we have different degree of deflection. If it is more polar, then it will be affect more, it will be attract more. The degree of deflection will be higher. For example, H2O, it is the superpolar one, the superpolar liquid. So H2O deflection is 4. The second one, it is ethanol. The ethanol is the second polar one. It has 3, the degree of deflection, while propanol, it is the third polar solvent. So it has the degree of deflection is 2. So the degree of deflection, although we seldom or we rare to find it in the past paper, but it can show at least whether it is a polar molecules or not. So you may refer to the experiment that are sounded or done by the textbook. That's the end of this part. Thank you.